me again. Okay, today what we're going to go through is chapter 30, organic nitrogen compound. It's a very crucial chapter in A2 in which the chances of it coming up in your exam is almost 100%. So what you're going to cover is amine, okay, the difference between amine and amide, and how you turn amine into amide. That you need to know that. At the same time, the second part is to compare the strength of bases. Okay, so comparing like what type of amide and what type of amines will have different strength of different strength as. Sorry, cut. This is another part. Cut. This is another part. Then phrase again. So the second part is about the basicity of amide and also amine. So you need to know how to compare and what to explain when we are comparing, for example, like alkyl amine, phenylamine, amide. What is the difference? So you need to know that. Okay, then again on formation of amide, you also need to know that, and also all the reaction of amines. So that will conclude the part 1 of this chapter. The part 2 of this chapter is about amino acid. So for amino acid, you have to know how it forms a Schweigel ion, and the another thing that is very important is the isoelectric point of amino acid and amino acid under different pH, what is going to form. So that you need to know. So the last part of this chapter is about electrophoresis, whereby you have to know the position of different amino acids at positive or negative terminal and what determines it. So I'll cover everything, and so please get your notes filled up, okay, because this is a very long chapter, a very long one, and I'm gonna go slow, and please follow the pace and enjoy the lesson. Let's go. Alright, come, let's go. Alright guys, for primary amines, yeah. So for primary amine, right, you always have an NH2 attached to an R group. Okay, so bonded to one LQ group, that is your primary amine. Okay, so guys, always remember, yeah, your NH2 bonded to just one R, that's the primary amine, yeah. Okay, so we indicate the position of NH2 by numbering from the nearest N. So always remember you number, okay, when you see N, right, you have to try to make the letters smallest, the number smallest, okay? So example, you see, this is 1, 2, 3, we count it from here, because amine is attached on the right-hand side, right? So we call it as 1 propyl amine. Or some school teacher will call it as 1 aminopropane, is also correct. Okay, so guys, this one, 1, 2, 3. So this is gonna be a 2 propyl amine or 2 aminopropane. So this is just a methyl amine, right? That's it. Alright guys, next we have a secondary amine. Guys, for secondary amine, right? Remember they have 2 LQ group. Okay, so there's 2 LQ groups attached to NH. So you see, right? Just now my N has 2 hydrogen, right? Now one of the hydrogen is being substituted by an R group. So you have 2 LQ group present. So this amine, right, we call it as dimethyl amine. This one, guys, NHCC. So you have 2 carbon, 2 carbon. So we call it as diethyl amine. That's it. Alright, guys, for tertiary amine, yeah, basically the nitrogen, right, no longer bonded to any hydrogen. Yeah, all the hydrogen being substituted. So you get 3 LQ group. So this we call it as trimethylamine. Alright guys, next part 2. Alright guys, physical property of amine. Yeah. So guys, amine, right, smell very bad one. So amine smell like rotten fish. Yeah. So small amine, right, is soluble in water. Yeah. Why? Because they can form hydrogen bonding, right? So highlight the word, all the amine can form hydrogen bonding with water. Okay, even the tertiary one, yeah. So guys, now let's look at your amine with amine forming hydrogen bonding, yeah. So let's say if I have an amine that looks something like that, I'm going to draw a skeleton now, yeah. Never mind now. Okay, so you have a lone pair, nitrogen bonded to hydrogen, able to form hydrogen bonding with H2O. That's your hydrogen bonding, yeah. Alright guys, now let's look at a short amine and a long amine. If you have a long amine, right guys, long amine is not soluble. Why? For example, guys, we have this long amine. Okay, so guys, if you look at the long amine, right, this entire hydrocarbon chain is non-polar, you know. So you have a long non-polar chain. Okay, so which means, right, the primary forces is ID. It's going to be ID is more dominant. Okay, which is insoluble, yeah. Alright guys, the same thing as the chain length increases, right, the solubility decreases, yeah. It becomes less and less soluble going down. Okay, so solubility decreases as the chain length increases. That's it. Alright guys, next. Let's get the smell. Smell is not important. We're moving on. Okay, so smell skip. Alright guys, let's look at the boiling point of amine. So primary amine, right, as you go down, as the chain length increases, right, the boiling point increases as well. Because you have more chain, means ID is stronger. That's it. Alright, secondary amine, tertiary amine, done. Okay, now let's look at primary amine. So boiling point of methyl amine is higher than ethane. Okay, why? Because the presence of hydrogen bonding, right, which makes amine having a higher boiling point. Where's the mean? Why everyone in Bali? Why? Is it a good season to visit Bali now? Yeah, I know, right? I mean, like, I don't really. I've been once also. Quite cheap, yeah, quite cheap. I've been once, but I don't have the urge to go back though. I don't have the urge to go back. But my friends keep on going back. Like, it's been their 5th times back to Bali. The beach nice. There got beaches, so that's it. Beaches, surfing, club, like a beach club, then got cafe hopping, got waterfall.
Hell no.
You youngsters can go. Why? Indonesia very cute one.
I'm from there, but like.
You from Indonesia, man?
I'm not. I'm half.
Huh? What do you mean by you half Indonesian?
Right.
Which half of your
mommy.
Your mommy Indonesia? Which part? Jakarta?
The kinky part. Kuala Lumpur. Medan. You know Medan?
Medan, I know Medan. From Medan, of course. I know one. Okay, so again, guys, primary amine has hydrogen bonding, right? Presence of hydrogen bonding, which makes amine having higher boiling and melting point. Yeah. Okay, now guys, boiling point of the primary amine increases with increasing number of alkyl group. Oh, so you mix.
No.
So do you go back to Indonesia?
Yeah, empty.
Why? Medan got food only, right? Medan got nothing to do, no?
Badminton?
Huh? Medan got badminton one,
I would have been.
You bring pickleball back to Medan.
You, bro.
Why?
Yeah.
Oh, your fashion.
Pickleball player cute, ma.
Damn zesty. Yeah, Loki, that's the reason why I will go.
Okay, increasing number of alkyl group. Okay, so why? Guys, again, because there's more electrons, right? When there's more electrons, you have a stronger ID. That's it.
Sir, could you scroll up to page 2 again?
Page 2, hiya. Okay, go.
Thank you.
Why you hate pickleball?
Paddleball.
I never tried paddleball though.
That one can bounce fast.
You go captain ball. No.
Chen, you know, I put you on, Chen. You really want to find a new one to touch with that. But if you want to find someone new, right, then one of them you go print out the
Dodgeball. Yeah, man.
the time I go back and then then
Sure, no.
could be some not sure whether it has no problem.
Wait, never go.
Because I'm not performing this.
Just play just dodge the ball only ma. Actually, dodgeball kind of hard.
Fucking hate dodgeball.
Wait, you too fat to not dodge, is it?
No, she's too fat, that's why the ball always hits.
Yeah, cannot dodge. That's why. Alright, guys. Next, we have secondary amine. So, guys, for boiling point of secondary amine, right, it's always lower than primary amine. Yeah? Okay, due to the decrease in hydrogen bonding. Why? So if you look at it, right? So for secondary amine, you only have one NH, right? That's it. Alright, guys, this part not important. I'm gonna go through it quite quickly. It's not important. Okay, last one, tertiary amine is having the lowest. Why? There's no hydrogen bond at all. You see, right? For tertiary amine, there's no hydrogen bond due to no hydrogen bonding found because there's no NH anymore, right? That's it. Again, guys, this is not important. I'm gonna we go through it quickly. It won't come out. It really will not come out. It's just
the tertiary amine.
yeah. You just have to know how to find how to identify whether is it primary, secondary, and tertiary. I think next year I will remove it. I'm removing this part already. Like this nonsense really not gonna come out.
The tertiary amine.
No, the entire page also will not come out. Yeah, because it's so AS. This entire thingy is so AS. IMF hardly come out in A2. In fact, never. IMF hardly or never come out in A2. A2 is always about the acidity and basicity. Okay. Okay, guys, now this is important. This will come out. So we have to slow down now. Okay, guys, amine, right? It's considered a weak base. I remember amine is a weak base. Why? Because on the lone pair, okay, electrons on the nitrogen atom. So the lone pair is able to accept a H plus here, which make it a weak base. Okay, so a base is a proton acceptor, remember that, yeah? Which means it accepts a H plus here. Can accept just one. Amine can just accept one proton. So guys, if you take amine plus a H plus, what it turns into? Go. It turns into a R and H donated shared one electrons to this hydrogen and turn into a plus, right? Done. Understand? So guys, this is a dative covalent bond, yeah? Because both the electrons are coming from your nitrogen atom. Clear? Alright guys, next, the strength of ammonia and amine as the base, okay, it depends on the availability on the lone pair. On the availability of your lone pair on your nitrogen atom to receive electrons, yeah. That's it. Alright guys, skip page 4, look at page 5. Come. I have a big table. You won't lah. Alright guys, page 5. Alright guys, let's look at the alkyl amine.
Thursday.
Oh, okay, can Thursday.
Tomorrow. Next week Thursday.
Actually, I forgot. Oh, coming back on Thursday.
Tomorrow.
Where are you going?
Danvina.
Oh, Danvin. Alright guys, let's look at LQ. Okay, amine. So amine attached to an LQ group. Guys, what did I mention about LQ group? What property it has on LQ? LQ has electron donating group with positive inductive effect, right? So which means LQ gonna push the electrons towards nitrogen, right? Am I right? So guys, which means the charge density here, the electron density here is okay. So guys, which means right, your electron density here is gonna be way higher. Okay, so if I put a H plus, right, what's gonna be? So this H plus, right, is high, very likely to go back to the very likely to be attracted by the lone pair, right? So very likely to be attracted Am I right? So which make alkyl amine basic. Either you get a basicity or you get an acidity. Alright guys, let's look at phenylamine. How does a phenylamine look like? Alright guys, this is a phenylamine. Alright kid, please tell me what will happen to the lone pair? Wow, I've done this story so many times. Ah, the playground one, yes. Remember this, so what the electron will do? Yes, it goes into the playground, right? Am I right? So remember, so this lone pair, right, will go into the electron ring, right? The pi ring system, or delocalize or overlap with the delocalized pi ring system. So guys, if I put a H plus here, right, is it more likely or less likely to be attracted? If I put a H plus here, is it more likely or less likely to be attracted? Less likely to be attracted, right? Why? Because the electron density here is lower, right? Get me? The electrons already delocalized into the pi ring system, right? So which make your H plus less likely, okay? So less likely to be attracted, right? So guys, this is a stronger base or weaker base? Weaker base. Well done, good job. So guys, remember, don't memorize, understand the concept, okay? So lone pair of nitrogen overlap with the delocalized pi ring system of a benzene ring. Okay, so again, decreases. I don't want you guys to use the word charge. I want you guys to change to electron. Okay, so change it to electron density. Why my notes right there? Why not editor? Wait, let me change it. Okay, so it's gonna be lower electron density now. So it's more difficult to accept a H plus, which means it's a weaker base. Let's look at amide. Okay, for amide, right, it does look something like that. You guys are really R, we have a C double bond O. Okay, we have an NH. Alright guys, I want you guys to highlight this O. Okay, please tell me, for this O, right? No, I'm still jobless. Alright guys, now let's look at O. Please tell me. Okay guys, please tell me more story about this oxygen. Yes, we done it before. This highly, yes, correct, highly electronegative. Alright guys, what do you mean by highly electronegative? What it's gonna do? So when you have this highly I did mention, right, oxygen highly electronegative is a strict parent, right? It's gonna draw the electrons all the way towards itself, right? Am I right? So the electrons will get drawn towards oxygen, you understand? So guys, technically saying, technically in actual, right? Okay, in actual, the lone pair is not there, you know. Okay, so the lone pair, right, was never there because the lone pair was drawn all the way to oxygen, no more already. So guys, can a H plus be attracted? Yeah, the lone pair being drawn to the oxygen. So guys, H plus are never attracted towards the O. Understand? Remember this, in amide, the nitrogen can never draw a H plus. Why? Because the lone pair was never there. Okay, so the lone pair was drawn all the way towards the oxygen already. Guys, again, is amide a base then? Can amide act as a base? No. Amide is never a base. Remember, highlight this, amide is neutral. Okay, I want you guys to highlight this, put 2 stars, put 2 stars, put whatsoever next to it. Most of the student will tell me amide is basic. Remember this, amide is never basic. Amide is neutral, pH 7. Please, this one very important, very tricky in the exam. Don't get it wrong here. Okay, why? Because you have oxygen, which is highly electronegative. Then oxygen is an electron withdrawing group. So the lone pair of nitrogen draws towards your oxygen. Lone pair no longer able to accept a H plus. Highlight the word. Lone pair no longer able to accept a H plus. Why? Because it's being drawn all the way towards oxygen. The dipole. Alright guys, now let's continue. We have ammonia, phenylamine, ethylamine arranged in ascending acid basicity. So again, if you look at do re mi, right? Okay, phenylamine is the least basic. I want you guys to put it here. Phenylamine is the least basic. Ammonia. And finally, ethylamine is the most basic. Why? Alright guys, now let's continue. Okay, ethylamine is a stronger base. Always remember, any ethyl, methyl, propyl amine is always a stronger base. Why? Presence of electron donating group pushing electrons towards your lone pair increases the electron density. Okay, so I can say that because ethyl group is an electron donating group, right? Electron donating group. So by releasing electrons to the nitrogen, the ethyl group makes the lone pair easier to accept, right? So easier to bond with a H plus. Ammonia is a stronger base than phenylamine. Why? In phenylamine, the p orbitals on the nitrogen atom overlap with the delocalized electron, well done, delocalized pi ring system in the benzene ring, right? That's it. So this causes the lone pair on the nitrogen in the phenylamine to be less able. No, I think to be what to be, bro? To be I put it as to be less able to attract a H plus. This make the lone pair harder to form a coordinate bond. That's it. Yes, correct. Benzene ring is technically an EWG, but you cannot write benzene ring as EWG. Understand? So benzene ring, right, the explanation is always overlap with the delocalized pairing system. But yes, it does similar thing, okay, compared to your EWG. Both of them, they will draw electrons. Just that you don't write benzene ring is EWG. Okay, EWG is always for highly electron-negative atom. So benzene ring, remember, is the playground story. The electron will always go into the playground. That's it. Okay? Come again?
Oxygen has two lone pairs.
Ah,
Oxygen is also highly electronic.
yeah. So depending on this OH, right, what is it bonded to? Depends on what is it bonded to. Let's say if it's a ring, it will still go in. But let's say if it's an EDG, then EDG will push it.
It's just outer group.
Just the outer group, as in like OH then? Or methyl group. For example, a CH3, right? Like that, a CH3OH. The same thing. This will still push the electron here. Okay? So OH group, right? You have to imagine OH group is always bonded to something that will determine the property of it. Okay, so OH alone, you cannot tell this is either basic or acidic. Okay, must be something bonded to OH, then only you can tell. Alright guys, let's go next question now. Let's do it. Let's look at why amide are weaker base than amine. Yes, guys, why amide is okay. So reaction does not work well because benzamide is a very weak base. Okay, guys, this is a benzamide. Okay, let's look at the benzamide. Why is it weaker than amine? Because the presence of, look at this, what do you call this again? Presence of highly electronegative oxygen atom acting as a electron withdrawing group, right? So I can mention that presence of Huh?
There, I thought, what?
Colourful.
Okay, so
Colourful.
how? So eventually, right, I can mention that the lone pair on nitrogen
Oh, hey,
is drawn towards the oxygen, right?
is it the one?
Okay, hence it's unable to accept a H plus. Yeah.
Don't see it's ugly and shit, but I expected
We were in. Oh, she was that fast last time. No.
Why this question cannot just say amide are neutral? Yeah. Okay, you see, right, Abby, whenever you state a statement, amide is neutral. Why? You have to ask yourself why, you know. So why? The why down to this statement. Why? Because presence of oxygen atom. Why? So you have to keep asking yourself why. Too much, right? So you can mention amide is neutral, but that doesn't tell you the why. You have to ask a few more questions to get this. Yeah, you can mention amide are neutral, but then like how? How is it neutral? You get me? Like why is it neutral? You still have to tell me why is it neutral, right?
No, but she also screams because yeah.
Alright guys, part 2 is fine, skip it. I want you guys to look at next page. Weaker base and neutral meant the same thing. No, weaker base not really meant, they don't really mean the same thing. Weaker base means they might still able to accept. Alright guys, page 7. Alright guys, now reaction of halogenoalkane with ammonia. Guys, halogenoalkane with ammonia, yeah. Okay, how do you get amine, right? It's halogenoalkane with ammonia. This is your AS reaction, yeah. You should recall your AS reaction. Okay, if you look at your organic hack sheet. Okay, where's my organic hack sheet?
But you know.
Alright guys, you see,
Yeah.
from a halogenoalkane turn into amine, nucleophilic substitution, initial in ethanol, heat under a pressure or in steel tube. That's it. So halogenoalkane to amine, nucleophilic substitution. What is even the question? Alright guys, now let's continue. Okay, so this is AS reaction, nucleophilic substitution. Yeah. So halogenoalkane is heated with ammonia. Okay, in ethanol, remember ethanolic ammonia, yeah. Okay, highlight the word heated with ethanolic ammonia under steel tube. Keyword in steel tube, yeah. Alright, so guys, now let's say if I have this ding, I add NH3. Okay, this is under pressure or in a steel tube. What is going to turn into? So you get an NH2 plus HBr, yeah. So you get a 2-butylamine. Am I right? Alright guys, once a HBr is formed, right? Okay, so this HBr, okay, so I think I need to do another substitution. Let's do a double substitution. So because the harder part is double substitution. So guys, I want you guys to cancel this line. Okay, I'm gonna teach you guys a new thing because this just came out this year. So I need to include it. So sorry, I haven't updated the notes. I just want you guys to write it down. So guys, if your halogenoalkane is in so if your halogenoalkane is in excess. Alright guys, if your halogenoalkane is in excess, yeah, so the product form, this 2-butylamine form, right, can react with your halogenoalkane again. Hassan, So one more time, so this is a brand new thing here. I think I need to edit my note already. Let me edit it now. Okay, so this halogenoalkane, let's say if it's in excess, it's gonna react with the product form. So it undergo another substitution. Guys, can you try to substitute it again? The concept is the same, guys. Look at how the substitution happens. Br is being substituted by NH3. How? Okay, which atom is being substituted? Hydrogen is removed here, so NH2 goes in. The same thing, hydrogen remove, Br remove, join them up. Guys, go and join them. So this would be a double substitution, yeah. A further substitution of halogenoalkane. So try to draw it out, go. Guys, want to draw? Done? Alright, so guys, you see, right? If you're not so sure, yeah. Okay, I'm gonna change this to a different color, maybe to a gray color. So this hydrogen and the Br will be substituted, right? So guys, to draw it out, you see, I'm gonna draw 1, 2, 3, 4. 1, 2, 3, 4. Just now was like that, right? Towards what? Towards the end, right? Correct. Okay, I'm just gonna tilt it like that. See, 1, 2, 3, 4. Okay, never mind. 1, 2, 3, 4. Can see. 1, 2, 3, 4. Okay. Nitrogen. By right. Just now was like that. Correct, guys. Am I right? Was the NH2 right? Okay, now you just remove the hydrogen and the Br here, substitute the gray thingy inside. Understand? Okay, guys, if you cannot understand, cannot visualize, 1, 2, 3, 4. Can see 1, 2, 3, 4. I just substitute this. Okay, this is not in the syllabus, but came out in the exam, Okay, so that's why now I need to teach you guys how to do your substitution again. You guys can substitute it one more time. If you guys do triple substitution, can it be done? You guys want to try triple substitution? Go substitute again. I want you guys to try a triple substitution. Yeah. You get a HBr here, then another HBr here. Well done. Yes, correct. Understand? This is a double substitution. Can you guys do a triple substitution? Alright, guys, try to draw a triple substitution. So far, I have never seen a triple substitution yet. I hope it won't be this round. But double substitution come out already. Okay, it was never in the syllabus, but out of a sudden just pop up. Then they just expect you guys to draw it. Alright, so guys, if it's a triple substitution, Tam, you got it right. You guys try a triple substitution. Okay, so triple substitution is gonna look a bit gay. It's gonna be like that. I'm just gonna draw it here. Then it's gonna be another NH, another wiggling line here. Wee. That's it. Guys can visualize. Know how the triple substitution work. If I color the wrong color, what do you mean by color?
Yeah, I don't understand. I wish you said.
Oh yeah. I think I understand. Yeah, it's the wrong color. The gray and purple should be opposite. Okay, guys, kind. So double substitution, please be careful. Might come out in the exam. Just came out, by the way. Actually, 2022 already have. Yeah. So now reactant. Okay, so guys, I have a halogenoalkane added with an ammonia. Okay, condition is your NH3, right, must be in ethanol. Remember, it must be in ethanol. Then you have to heat it under pressure or in a seal tube. Reaction, halogenoalkane turn into a amine, turn into a secondary amine. If turn into a tertiary amine, if you keep on substituting it, understand? Mechanism, nucleophilic substitution, understand? This AS stuff. Oh, your socks is different color. Oh, so cute one. Oh, okay, okay. Hey, you still wearing that? You still need that?
Oh, 这是蛮多的。
It's bro. Bro, it's been a year. The first time I get to know Kaylin, right, was wearing the what do you call air boots, right? Until now, is it still? Walao eh. Okay, guys, please write it down. Yeah. Yeah, the first Kaylin with the crutches, bro. Okay, next we have reduction of nitrile. Yeah. Alright, guys. KCN in ethanol is heated under reflux with a halogenol alkane. 雪玲, yes, go up. Hey teacher, when you will teach ionic equilibria? When I'm done with this hard right ionic equilibria. Last chapter. This is the last one. Yeah. Organic is not long, but a lot of understanding and memorizing. A2 organic is relatively shorter. pH part, bro, don't worry, Sherling, I'll make it very easy. But ionic equilibria is considered one of the toughest chapter. Alright, guys, next. KCN in ethanol. So if I have a halogenol alkane again, okay, and this time, right, I'm gonna add a CN minus.
Then what?
Okay, you get a C triple bond and a Br minus, right? So you are getting 1, 2, 3, 4. Okay, so 1, 2, 3, 4. Wait a minute. 1, 2, 3, 4. Shit, wrong already. GG. Sorry. My one carbon missing. Now I add another one here. So 1, 2, 3, 4 turns into 1, 2, 3, 4, 5. Yeah. So this will be a butane nitrile. Alright, so guys, once you have a nitrile, right, this nitrile vapor, okay, and hydrogen gas are passed over a nickel catalyst, right? Okay, or LiAlH4. You can use LiAl. I would recommend you guys to use LiAlH4, the general reducing agent, the universal one. Then eventually you get an amine. Yeah. So I take this, guys. You see, I take this ding. If I right. Alright, guys, next what it will turn into, this is a reduction reaction, right? So you get an amine, yeah. So the triple bond is gone. Yeah, bro is going deaf, bro. Sis is going deaf. Alright, so guys, that's it, yeah. So guys, you see, right, how many hydrogen we are adding, yeah? So basically, we are adding 1 hydrogen here, 2 hydrogen here, 3 hydrogen here, 4 hydrogen, right? So basically, you are adding 4 H, understand? Correct. So it turns into a pentylamine. Oh shit, I lagging, sorry. Can see or not? Your tertiary amine, faster. Here, now go. So that's how we get amine, guys, from a halogenal alkane, okay, turn into an amine, or from a nitrile, turn into an amine. Both reaction are from ES, yeah. Okay, guys, reactant-wise, let's go. What do we need? Halogenal alkane. Okay, plus CN minus. Then add with a LiAlH4. or a nickel catalyst? Okay, so guys, from a halogenoalkane, you can turn it into a nitrile. Wait, I have one more chat coming in. Yeah, you correct. Maybe you have another bromo alkane, but just that I never write it down. I just draw the organic product. So halogenoalkane turns into a nitrile. Okay, then from nitrile, you can turn it into an amine, right? So guys, the first reaction here is SN1 or SN2 substitution. Yeah, that's the mechanism. The second reaction, the mechanism is reduction. Yeah. Yeah, this is in your AS. It's actually AS stuff. This entire part, right, is AS. Yeah. Alright, guys, next reduction of amide. So guys, if I take an amide, right, you can reduce amide into an amine. Yeah. So amide can be reduced into amine by using LiAlH4. Alright, kid, let's go look at this amide. Okay, it's an amide, right? Guys, I'm just gonna add LiAlH4 and a reduction reaction will occur. Go. So what's gonna turn into? So guys, the double bond O, right, will get reduced off, and you don't have an O in your alkyl, in your halogenoalkane, sorry, in your organic compound no more. So the O is kicked out. Okay, so guys, how many H we are adding? Go, please tell me. You see how many H we are adding? 1, 2, 3, 4. So we are adding 4 H here. Understand? Alright, guys, now. Okay, let's look at the reduction of amide. So you're starting with amide, right? Condition and reagent, you just have to add LiAlH4, yeah. Okay, reaction from an amide turns into an amine, and the mechanism is just reduction, yeah. Done. Yeah. Alright, guys, now there's something new, preparing a phenylamine. So guys, how do you get a phenylamine, right? The only way to get a phenylamine is by reduction of nitrobenzene. Okay, so highlight the word reduction of nitrobenzene. So this reduction, right, is carried out by heating a nitrobenzene with a hot tin, which is SN. Okay, and concentrated HCl. Highlight tin and concentrated HCl. Any Taiwanese here? Any Malaysian mixed Taiwanese? No, we have Japanese, we have Korean.
Who's Japanese?
Yeah, the guy with Takito lah.
Oh, who's Korean?
Korean online kid, not here.
Does he look like Jungkook?
You ask him. Alright, guys, now we have a nitrobenzene. Does he look like Jungkook? Why everyone is Jungkook? I thought you guys are the G Dragon, not G Dragon man.
No.
Jungkook.
Sure.
Really? G Dragon coming Malaysia. Is G Dragon coming Malaysia? No, yes. I heard the news, they say G Dragon coming to Malaysia. No, it's not. Alright, guys, you have a nitrobenzene. Okay, so you're gonna turn this into a phenylamine, which is a NH2, yeah. Second, I'm marking attendance. Alright, guys, reactant wise, where's my reactant? Hey, sorry, I haven't balanced the equation, right? You see, you have two O, both O, right, will get kicked out as a H2O, correct? So eventually you have 1, 2, and 2 O, right? 2 H2O. So 1, 2, 3, 4, 5, 6. You need 6 H to balance it, yeah. Done. Alright, guys, again, nitrobenzene condition. I need hot tin and concentrated HCl, yeah. Who? Yeah, he retook AS. He done it. Look, graduated already. So nitrobenzene.
Idris lah.
Look Idris, why you like him? Turn into a phenylamine, right? Oh,
Hey, you quite cute.
he quite cute, what?
Oh.
No lah,
He's damn hot.
all my students are cute. Of course, right? I get all the hot students, huh?
Just say you.
Other teacher must be damn jealous. Okay, nitrobenzene turn into a phenylamine reduction reaction.
You think Kap's gonna come to school tomorrow?
Probably. Don't feel awkward when you like very seriously.
He just say only.
Okay, guys, done. Okay, next. The reaction with phenylamine. Okay, so guys, phenylamine, right, can undergo electrophilic substitution. So guys, you see, right, the moment you see the word electrophilic substitution, which means, yeah, the substitution is happening on the ring, understand? With aqueous bromine under room temperature. Okay, where a white PPT is formed and a white film is liberated, yeah.
What happened to that Chinese lady? What happened to that Chinese
Who is Chen Yi? The guy? No, Chen Yu. She graduated already.
Oh, a friend?
It's the bad thing. She dropped out.
No, Chinese didn't. I thought.
Chen Yu finished already.
Alright, guys, you see, right? When the substitution occurs, okay, so this substitution, right, is gonna happen on the 2-4 position, the second and fourth position, okay, and sixth position will also get substituted, yeah. So, guys, I want you guys to draw a tribromo. Go draw a tribromo here. Alright, guys, what it turns into? Miss Joanne. Alright, guys, this part done, yeah. Page 10, let's go. I'll go find her.
Says two.
Okay, so NH2 has a 2-4 directing effect, yeah. Hmm? Who? Which one? Which one electron withdrawing? 2-4. Hey, 3-5, 3-5. 2-4 is electron donating. Okay, guys, again, if you're confused about your electron donating group, which position, right? The only thing that you need to know is this one. Remember, yeah, guys, for your LQ group, right? You see, any R group that we have, yeah. Okay, any LQ group that we have is always 2-4 position. I see. LQ is always 2-4. Remember, if it's a CH3, any incoming will always go into 2-4. Okay, NO, NH2 is also the same. Also go into 2-4. But electron withdrawing such as COOH, can you see that? Then it's 3-5 directing. X, for example, if your X is a CH3, then incoming is gonna be 2-4-6.
Let's say you have CH3 at X, then undergo nitrification.
Still 2-4. It depends on what is bonded. Understand? Not what is coming in. What is coming in doesn't matter. What is bonded matters.
Nothing bonded.
Then anywhere. Just anywhere. Alright, so guys, reactant wise, what do we need? Phenylamine plus Br2, right? Okay, and room temperature. Okay, guys, I get a phenylamine. So undergo a electrophilic substitution, you will get a tribromo, okay, phenylamine, yeah, which is formed as a white PPT. Mechanism, electrophilic sub. Please like and subscribe. So someone can take it. Please like and subscribe.